Hello, everyone. This is Ray Savage from Cambium Networks. Thank you for joining us for this year-end webinar. Today we have a very special webinar on migrating your network to ePMP technology. And we have two very special guest speakers today. We've got Josh Luthman, who is the president of Imagine Networks, and also Matt Perkins, who is the president of IntelliPop. And joining me here in the studio is Dmitry Moiseev, who is one of the lead engineers for the ePMP product. Before we get started with the webinar itself, I just want to remind you that the presentation is being recorded, and all attendees will get a copy of the recording. We will also post the recording to the community so that you can view it there and also ask questions and answers there. But during the course of the presentation, if you do have any questions, please use the question and answer box on the right-hand side of your screen, and we will be able to pose your questions to either Josh or Matt during the course of the presentation. Well, without any further ado, I'd like to turn us over to Josh, if you'd like to speak first about what you're doing with Imagine Networks.
Yeah, sure. So we're a small wireless ISP, started in 2006. We basically just bought a network from another company that was kind of struggling to make it work. We just started by taking down some of the towers that weren't making any money in areas that didn't really make sense, and we just started putting up access points and things to try and get internet service out in the middle of, quote, nowhere. Most of the houses and stuff that you see in these pictures, their option is either dial-up, satellite, or us. So the struggle for bandwidth is pretty tough. We have our office in Troy, which is about 30,000 people, and we were lucky enough that the building had a 40-foot tower on top of an already 40-foot building, so that's where our fiber comes in. Phone company had its stuff there, cable company brought in fiber, stuff like that, so that's where our internet comes in at. And then we just started doing wireless backhauls and just broadcasting it out. Yeah, obviously the equipment that we put up, 4 or 5 years ago just doesn't really cut it anymore, so we started putting up new stuff. For the last year and change, we've been doing strictly ePMP, both 2 gig and 5 gig. 5 gig has definitely been our saving grace. It's just the additional frequencies that you can use, and the 5.1 band are fantastic, and then the spectrum reuse is all fantastic and everything like that. As you can see in the pictures, the terrain that we're dealing with, lots and lots and lots of trees. I think this is about 350 feet up, so you can see pretty good far out. Most of our links end up going maybe 4, 5, 6 miles. That range for the most part. Sometimes we get pretty lucky where customers on a really serious hill, and those customers are like 10, 12, 14 miles out. You can stand on our front porch and you can see almost the base of the tower. It's pretty cool sometimes. Not a whole lot of really hilly stuff, so that doesn't really come up too often. So we deal with a lot of penetrating a couple of trees here and there, but not a whole lot. The main reason we also stick with 5 gigahertz is due to just simple noise constraints, as I'm sure most people are starting to deal with. 2 gigahertz is just turning into pretty useless even out in the rural neck of the woods. Everything from their cordless phones to gaming controllers to anything and everything nowadays. Everything's got to be wireless. It's just too much work to deal with running a wire between the computer on the left side of the desk to the router on the right side of the desk. So it's all wireless. We can go to the next slide here. So yeah, again, back to noise. On the tower on the left, that's a couple years old. It's only got 2 6-foot dishes. That's when they first started getting really noisy. Those are point-to-point 600s put up by the company that owns the tower. They do a lot of stuff for first responders. There's a handful more 6-foot dishes. There's probably, I don't know, 1 to 2 million FSK APs at the top. It's insane how much stuff that they put up on there. You'll see a whole bunch of reflectors and things for smaller backhauls as well. And the one on the right is our shared site with now AT&T and Sprint. It used to include Nextel, but obviously Nextel's gone. So obviously they have a ton of stuff on the top of the building. They have all kinds of license links, and I don't think they use too much unlicensed, but as you can imagine, Ethernet does become somewhat troublesome. We've got 8 ePMP access points on there, 2 north, south, east, and west, each direction, 4 backhauls, north, south, east, west. We've had 0 Ethernet issues on that, so we're pretty lucky and pretty happy about that. We first put that up right around a year ago, I think November 2014. It was our first deployment, and it's been rock solid ever since. We've had 0 issues with it since we started it. It's also a DC site, so that may help. You know, that's powering it via DC has been really helpful for us, and as far as battery backups, it's really nice as well. The only downside about this site is that there is 0 Ethernet at the base. 100% of the stuff is up at the top. But as I said, we've had 0 issues, so it hasn't been a problem whatsoever. We can go to the next slide here. Okay, so as the title of the presentation shows, we're talking about migrating to ePMP. So as you can see, I've got a couple access points here on the building, and we're starting to overlay the ePMP stuff on top of our previous coverage. Just last week I was talking to a customer, and he had some sort of an issue with, you know, his IP, forgot what his IP address was or something like that, and he has a couple of static IPs. He works for a pretty good sized company down south of Dayton, so instead of driving an hour south, he just stays in his NS-Warm office, and he's got a whole bunch of bandwidth through ePMP. So we moved him from some of the older equipment to ePMP, and he could not praise the equipment more. He was so happy, so excited for the last couple of weeks to be on the new stuff, and it was working so much fantastic for him. And most of the time, we try and do 5.7 first. If 5.7 is already full, some of the older stuff, we'll do 5.1. The power output is pretty relatively close. It's not the exact same, but it's close enough that the coverage ends up being about the same. But having another, 100 some megahertz at the bottom is really nice, especially when you want to avoid interference with your own stuff, let alone outside noise. In this shot, I did a spectrum analysis, and there was almost 0 noise, but this is about 40 feet above the ground, so there's not a whole lot of stuff that I can really see. We get about 2, 3, 4 miles, give or take, on these sectors. And in most cases, we're using 20 megahertz channels and get right around 70, 80 meg aggregate. We can go to the next slide. So this is a real-life example, as I'm sure pretty much everybody's really wanting to see. At the end of January, we started having a lot of bandwidth constraints and a couple of complaints from customers that the AP that they were on here was just not cutting it. They were having issues, and they didn't really know what was going on. And so we looked at this. It was just old 802.11 equipment. So we went up there, and at this point in time, it was running 2.4, so Wi-Fi mode was not an option. So we went up there and put up this AP, and then we just started swapping out all the customers over the weekend. And obviously it didn't happen a Friday night, but it happened over that 2-3 days. We'll come to find out that Monday morning, you could just start seeing all the increased bandwidth usage. So obviously the AP was not able to provide enough for all that, the demand that we had sold all those customers. So by simply switching it over to ePMP, we improve the quality of all the customers, and everybody's just a whole lot happier, and the calls just instantly stopped. You can see it's gone up a little bit. It doesn't show the peaks very well, but the peaks are substantially higher. They're usually 25, maybe 30 megs on, Friday nights whenever it's Netflix o'clock. Now, back in, I would say 2-3 months ago, obviously with the additional expense of the AP, we just started calling up a couple customers, and we just started upgrading to a higher plan, and then a couple of customers switching saved us the cost of the equipment, saved us the cost of the additional rent, all that kind of stuff. So, by simply switching out this AP and the customers, we started making more money, and the customers are happy. It was a good thing on both sides. This particular AP shooting out to the east, it was actually the pictures from that first slide. We have 15 people coming off of it directly with the SMs, but then as I said, there's a lot of trees and things, so 5 of those 15 SMs are actually little micro pops to get around the trees of the tree lines, and those are just little 2.4 omnis and such. And as it says there's 40 active customers behind this AP. So you can see that the daily graph there, the daily graph shows the 25, and that particular day last week it didn't do quite 30 megs, but it definitely does hit 30 megs pretty regularly. And this is on one of the noisiest sites, and this is in 5.7. It's at 5.825 if memory serves. So we're really happy that by simply swapping out the radio, we got a whole lot more bandwidth, and it's just been a great situation. We can go to the next slide. So as I'm sure everybody wants to see, there's a speed test. You just simply hit the button and it does it for you. This is done at the MAC layer, so it's obviously not what you're going to see on speedtest.net or Ookla stuff or whatever, but it gives you a relative figure to work with. So by seeing 80 by 35, I mean, even if you saw half of that, I think most customers would be pretty ecstatic. And again, this is the same AP that we're talking about as in the previous slide. There's 15 SMs. I'm running in flexible mode. I don't have a need for sync at this point. I just need to power through and get all the 802.11 stuff out of the mix. Again, 20 megahertz. We're actually not using the OEM sector. We're using the KP sector, which has worked out pretty well for us. We use KP sectors almost exclusively for the last several years. We've been pretty happy with them. In this particular AP, we have a customer that is at the weakest is -72. We at this point have gotten pretty picky with our installs. We don't install at like -80, -85, stuff like that. We have other towers and stuff that we can put them on. So once the point we got to the point where we were grown enough to the point where we have multiple towers, that's kind of a luxury we can have. But when you're first starting out, that simply was not the case. It's certainly not for us. And in this particular AP, the farthest customer is 4.7 miles out. I think on the new AP that we just put up a couple weeks ago, we're easily going to beat that. But we'll see when we start moving out customers. And as you saw, the one thing I didn't mention is that this is I believe we moved this down to 2.5 millisecond frames. So the latency is pretty remarkable. The average is 16 milliseconds, as you'll see down there, and that was right during prime time while it was delivering 25 megs. So it was really cool to see really nice low latency. At the same time, it was delivering quite a bit of bandwidth. We can go to the next slide. And this would be Matt's train.
Yep. Thanks very much, Josh. Josh, we did have one question that came in while you were talking. That was roughly how many subscribers do you have in your network that are on ePMP right now?
That are on ePMP right now, off the top of my head, I would probably say around 75 to 100.
Great. Thank you very much. Our next speaker is Matt Perkins, who is the president of IntelliPop. Matt, are you with us?
I am. Can you hear me?
Oh, good. You sound fine.
Okay. Wonderful. Well, I think president is a interesting term in a small wireless ISP because I think that means that I take the calls, I climb the towers, and I make the network work and build out the new sites. So I've got a lot of hands-on experience with ePMP next to ubiquity that we had in the network, still do to this day. Our train that we're kind of dealing with here is, as you can see, we're kind of valley hopping. We're at the edge of one, and then we shoot all the way through the base and up to the edges of the other. We find that our customers that are more interested in purchasing the higher end plans tend to be higher up on the mountain, and the customers that are looking for more of the base plans are closer into the valley. Not always the case, but it's pretty common in that setup. As far as our customer kind of layout, we are in a weird environment where it's a lot of nothing followed by a really dense subdivision. So, we have to have coverage that overlaps on our APs so that we can get enough subscriber density in those larger subdivisions and still be able to provide high throughput. In our market, customers are expecting anywhere from 15 to 50 megabits per second. And we offer that through a kind of a bursting system. Our guaranteed speeds are 5, 10, and 20, respectively. how all of that works for us is actually pretty well. Customers are very happy. We've never had been able to offer even our 30 meg service reliably on the previous equipment, which was Ubiquiti N gear, and we've been super happy that we've been able to offer it reliably with ePMP, and we're always trying to find a new way to maximize ePMP to give us that extra throughput, the additional access point count for additional subscribers. I mean, our goal as an ISP, a wireless ISP, is to make the most revenue possible out of each tower site, not necessarily to have a lot of tower sites. So we're quite excited about the opportunities that we have to provide a dense service and utilize ePMP to help provide that dense service. We do have some RF challenges. Being that we're in the middle of nowhere is nice for the tower site, but when we get down to the subscriber sites, there's a lot of noise. A lot of noise in those dense subdivisions, and you're shooting right over everybody else's roofs, so you pick up a lot of noise. There's a few other wireless ISPs that we're out there in the market with. Some are Ubiquiti, some are Cambium 450, and we do occasionally run into some issues, but generally we can get through it with the proper use of a high dB gain dish. We almost exclusively deploy Force 110 in this higher noise environment. The reason for the decision with Force 110 is, it's always better to have a couple extra dB than too few. So for the price point that Cambium offers, that Force 110 product, and soon to be the Force 200 product, we are very excited about using that product in terms of its continued ability to deliver reliable bandwidth to our customers. Next slide, if you could, please, Ray. So as you can see, this is the tower that we started with ePMP on. It's got 3 Ubiquiti antennas at the top, shielded, and then we've got an 11 gig backhaul, which used to be a 5 gig backhaul. So we moved that from 5 to 11 in order to facilitate some additional band space to hang ePMP radios. You'll see that we've got 4 on the lower section with one of the standard Cambium bars, and then we have 1 ePMP radio at the top section. There's actually 1 additional radio hidden behind the back that points the same direction as the one on the top. You'll notice that we're not running Cambium bar sectors. We did for a long time, and they were very, very good sectors, but we got to the point where we had a really unique situation. We have 2 small communities that are both very dense and very small from the tower's perspective in terms of azimuth, and we needed a way to concentrate that energy and deliver multiple overlaying access points. So as of today, we have no frequency reuse on this tower, but we've just barely hung these new horn antennas, which you can see have some crazy benefits. The spacing on the tower, we're able to pack in the APs now. We've prior, using the larger bar sectors, we only could get about 4, where you see the 4 that we have there, and now we have 4 plus one of the larger bar sectors. So it's really freed up the tower, and a big concern for us on that tower was wind and ice loading in the winter, which is right now here in Utah, and that has substantially reduced that load, and so we're able to add some additional backhaul antennas up there as well. So the last advantage is we're trying to get really tight beam widths. We're trying to figure out a way to do frequency reuse on the Cambium equipment at less than 180 degrees. So we're hoping to do it in as low as 80 or 90 degrees, and we'll keep you guys updated if that succeeds. But part of the RF challenges, again, we're sharing that space between some legacy and Ubiquiti equipment and the Cambium equipment that we use today. Both are on the same 5 gig spectrum, and we run 20 megahertz channels across all of our access points. Now, one big thing to be said about running on ePMP versus the end product from Ubiquiti is the channel spacing. We can, and this is done currently in our environment, we can actually space the channels only by 5 megahertz, and we experience no degradation to the access points that are sharing that band space. So that's a huge win. When you're trying to hang as many radios as we are on a tower, to only have to burn 5 megahertz in between, that's great. We had seen on the older products that we'd need 20 or more megahertz to separate them without causing issues with with quality on the links. And even then, our densities are double. So you kind of heard we had some pretty aggressive offering when it comes to residential service and business service on the speed packages. And so we're able to get double our previous density. So that the end sectors, we really saw degradation after about 15 subscribers in the noise that we're in and in the bandwidth delivery kind of requirements that we have. So they would fall short of just over 15, and we're able to get to 25 to 30 now per Cambium AP. And this tower that you're looking at right here services about 150 customers on the ePMP product. So it's pretty exciting with what we're able to do there. Ray, can you bring us the next slide? So more on the performance. We're seeing more than 2 times capacity over the end product. The other really great thing, we had never had any success running VoIP over the legacy product, and with the quality of service options that are available from the ePMP standpoint, we have very good luck now. We don't provide VoIP ourselves, but we do have many customers who use it, and they expect it to work. They don't want to know what the details are that go behind it. They just want to plug in, and they want to have their Umla or their Vonage phone service work. And so we're able to provide that prioritization on the packets that come from the SM up to the AP, and it really does help. The other thing, same that Josh mentioned, when Netflix o'clock hits, we don't get complaints anymore. We're able to saturate the APs and utilize it. I have seen an access point writing at 90 megabits per second before, the aggregate throughput, and that's great. And that's on 20 meg channel, and that's with capacity to spare. And so that has been a really exciting thing for us. We run in flexible mode right now because we have not been able to get the GPS synchronization configured appropriately yet, and we didn't have the biggest reason for that was our towers don't provide us that 180-degree offset. We are building our towers along the hillside, so we only service half that area, and not even half. It's significantly less. And the two communities that we mainly service in the tower that you saw in the picture there, they are not 180 off of each other for heading purposes. So back-to-back frequency reuse isn't a possibility. So that's why we're moving to a different antenna type to try to obtain frequency reuse in 80 or 90 degrees, which we're excited to try and see how that works. It hasn't happened yet, but it's just because we haven't had time to try it with changing weather down here. Again, better use of spectrum with ePMP product, 5 megahertz separation between your access points, and over 100 megahertz or 100 megabits per second on a 20 megahertz channel is phenomenal. The speed tests you see below are on the right. The Ubiquiti sector had 14 subscribers on it, I believe, and it was a similar signal. And these two customers are actually neighbors to each other, and you'll see that we got about 20. And I just did the receive test on Ubiquiti to get the most optimal results to show you. But the best we could get off that one customer is 20 megabits. And the access points at the time that the test was done, we actually had more traffic going through, and I didn't write the numbers down, but when I had them up on my screen both side by side, we had more traffic going through the ePMP access point at the time that I ran it than we did through the Ubiquiti. And I ran a test about 4 or 5 Ubiquiti ones in that same subdivision to try to find the best one, and this was kind of what I came up with. On the ePMP, I can go to any AP, and I can see the speed result from the subscriber back and both ways. So you can see this did an uplink and a downlink, which is slightly less than what Josh had shown, but that's mainly because we've got, I think we probably had a little bit higher of a load on the AP at the time that we pushed this test. So overall, I mean, with the Cambium product that we've experienced ourselves, it's that reliability of service that you deliver to your customers. It's the continuous expected response from the Cambium gear. You don't troubleshoot weird anomalies. The weirdest thing that we've ever had happen with the Cambium gear is we broke one of the leads on the Force 110 antenna going to the SM, and we obviously had modulation, but we had a great signal, and we were troubleshooting to find out why. And we pinged someone at Cambium, and they said, oh, this was before the E-Align tool. They said, oh, jump in the CLI and run a get RSSI, and sure enough, we had one pole receiving a perfect signal and the other pole nothing at all. So with the new E-Line tool, that has greatly been improved. You can go to, I should have given a demo on that, but you could go to the E-Line tab on the ePMP radio, and it'll show you both polarities, and it'll show you, a second, less than second update of the current signal, and it has a really great historical graph that'll show you your top signal, and then as you sweep, and then so you know kind of what the best signal you got during the sweep was, and you can try to re-obtain that signal. I can tell you from our installer's perspective, that tool has been absolutely amazing. So we're very excited for that. Do I have another slide, Ray?
Yes, you do.
Yeah, same topic. So yeah, there's more details. ePMP sector had substantially more subscribers. I guess I was a few subscribers off on the UBNT one. That was actually 17, not 14. We're running 20 meg channel sizes. The AEPs were in 5.8 and 5.2. Similar RSSI and subscribers within the same block, both clear line of sight. Is that the last slide, Ray? No. I should remember this. I did it over the weekend. So we run the Force 110s, like I said, for shots over 2 miles. And that's not to say that in your environment you would have to go that way. That's because we're in a high noise environment, and we are trying to plan for the future and always keep our signals clean, so that if a competitor rolls in town, we don't have to worry about all of our shots being degraded because of the additional noise. We'll have that extra few dB. If you look at one of our APs today, the worst signal on an AP is an NIC65. And we do that on purpose because, like I said, high noise, high interference, and it's always possible that someone could put up a radio right near where you're at. And so we choose Force 110 whenever it's a longer shot. For us, longer is over 2 miles. Our longest subscriber shot's around 5 miles. Our APs are configured to do a max of 6 miles. But yeah, greater gain, noise reduction over the integrated. But the new Force 180 SMs are actually really good. We were super surprised at the performance we were getting out of them. So I would definitely recommend checking out those SMs if you can get your hands on them. They are really impressive over the original integrated ones. And the biggest thing on the 110 is kind of the cost and you receive the dish, the radio, and it's all a really reasonable package price. And the Force 200, we're super excited for that to hit the market, because the only downside of the Force 110 as it sits today is it's just a little bit labor intensive on the assembly. But once it's assembled and it's in the field performing, it's a rock solid machine. Next slide, Ray. So again, to speak to that quality hardware, we had an electrical discharge event in a neighborhood where we had a pretty dense subscriber base, and every single neighbor reported this lightning strike to us that we went and serviced. And we went and checked the map, and we had 4 ePMP Force 110 units deployed in between the 3 ubiquities that died. They were cabled to the same standard. They were all the same setup in terms of the outdoor stuff, but the ePMP units somehow survived the discharge event where we lost 3 ubiquity units and had to go out and swap them. Of course, when we went to swap the 3 ubiquity units, we did move them to ePMP, and that's just because we have some really good belief in the hardware that we've got. So I actually did an update on the count. We have closer to 140 SMs deployed, 120, but no AP failures at all, which is great, seeing as we've had several AP failures on the other configuration, and we officially deployed this about 12 months ago. So all in all, super happy with the ePMP product. We're really looking forward to the evolution of the new products that are coming out to enhance the ePMP product line and to simplify it for our installers.
Excellent. Thank you very much, Matt. I'd just like to remind everybody that you can follow us on social media. You can pick Facebook, LinkedIn, Twitter, Google, or Weibo. And the Cambium community is a great place where you can meet up with other network operators just like Matt and Josh and learn from their experiences. It's cost nothing. It's at community.cambiumnetworks.com, and there you'll find discussion forums on products, network planning. We have sections in different languages. We also talk about business issues there as well. There's a knowledge base with technical detail documents, and those details include things like the E-Align tool and channel spacing that Matt mentioned in his part of the presentation. There's also an area where you can submit your development ideas, and our product management and development team actually does review that, and we do execute those based on the prioritization and what capabilities we're adding. But in addition to that, there's an area where you can share your real-world connectivity stories and ask questions of network operators, just like Matt and Josh. Well, Matt and Josh, some questions came in during your presentation, but your slides actually answered those, and people were very appreciative of that, so we have no questions in the queue. It is almost the end of the year, and I'd like to thank everybody for their business, and we certainly look forward to a very progressive 2016 where we've got a lot of new things coming out. Thank you, Matt. Thank you, Josh, and thank you, everyone. We'll look forward to seeing you on a future webinar.